So today the next session is on the partial differential equations. So we have already learned about the boundary value problems. That is a solution of a differential equation of second order of the form f of x comma y dash or y double dash. So this equation contains two arbitrary constants and these constants are determined by means of two conditions. So we know the two conditions. If you know the two conditions, then you can proceed and find the values of in between value or conditions, x values. Okay. So a differential equation together with the boundary conditions is called the boundary value problem. And the partial differential equations are actually the differential equations which involve more than one independent variable. So the variables which determine behavior of the dependent variables. Okay. For example, the displacement of vibration spring, heat flow equation, fluid flow analysis, etc. So here we can see the partial differential equation of second order with respect to two independent variables x and y. That is a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square plus d dou u by dou x plus e dou u by dou y plus fu is equal to f of x by the function. So this can be expressed of the form a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square, and the last three terms it can be written as a function of x, y, u, dou u by dou x and dou u by dou y, which is equal to 0. So this is the equation which is the basis for differentiating the partial differential equation into three forms. One is the elliptic equation, the second is the parabolic equation, and the third is the hyperbolic equation. If just find the coefficients a, b, c and do the procedure b square minus 4ac, find the value. If it is less than 0, we can say that the equation is an elliptic equation. If it is equal to 0, it is a parabolic equation, and if it is greater than 0, then it is a hyperbolic equation. Okay. So first we are going to start with the elliptic equations. So the two forms of elliptic equations are Laplace equation and Poisson's equation. Both of the equations you have to learn. Okay. So in Laplace equation, the equation will be of the form del square u equal to 0. That is del square u, it is a form, del is actually the form uh, for representing, that is, sorry. So del is actually dou by dou, your del square is actually dou square by dou x square, then plus dou square by dou y square. So this is the form for del square. Okay. So del square u, if the equation is del square u equal to 0, then you can say that the equation is a Laplace equation. That is, the right hand side is equal to 0. If the del square u is equal to a function, then the right hand side is not equal to 0, then you have to solve it using the Poisson's equation. So these are the two equations. So ചിലപ്പോൾ question it will not be specified whether Laplace or Poisson's. Just see the right hand side. If it is equal to 0, use the Laplace equation. If it is equal to a function, use the Poisson's equation. Okay. And the second classification is parabolic equation, and the equation is dou u by dou t is equal to k into dou square u by dou x square. So our usual one-dimensional heat conduction equation is an example of parabolic equation. And the third is the hyperbolic equation where b square minus 4ac is greater than 0, and the condition is dou square u by dou t square is equal to c square dou square u by dou x square, which is an example of one-dimensional wave equation. Okay. We can start with the first condition here, that is the Laplace equation. So the equation is del square u equal to 0, that is right hand side is 0, or the equation will be of the form dou square u by dou x square plus dou square u by dou y square equal to 0. So in order to solve this, we will be actually classifying the whole area into a number of rectangles, and we will be bothering about the points, the intermediate points. Okay, so these are the intermediate points at which a particular functional value has to be determined. All the boundary condition values, this thing, and all the boundary values will be given in the question. You have to determine the intermediate, this dot values. Okay. So the two formulas which I use for this is standard 5-point formula and diagonal 5-point formula. Standard 5-point formula, it is given here. That is, we are going to determine the value of the midsection uij. We have to use the standard 5-point formula. That is ui minus 1j. That is 1 by 4 of ui minus 1j plus ui plus 1j plus uij plus 1 plus uij minus 1. Okay. So the average, it will give you the value for uij. It is a standard 5-point formula. Now diagonal 5-point formula is this thing. If you know the value that is this point, the value at the uij will be equal to 1 by 4 the average of ui minus 1j plus 1 plus ui plus 1j plus 1 plus ui minus 1j minus 1 plus ui plus 1j minus 1. So this is diagonal 5-point formula. So here we will be using a Laplace iteration process in order to solve the Laplace equation. I will tell you the process. You are asked to determine all the values. You can see B1, B2, B3, etc. up to B16. So these values are the boundary values which will be given to you. You have to find out the value of U1, U2, U3, U4, U5, etc. up to U9. Okay. So all those values you have to determine. So how will you start? You have to start with the central value, that is u5. So first determine u5 arbitrarily, or just it is an assumptional value. So how to determine this u5? You have to use the standard 5-point formula. So we have to consider the points B11, B3, B7 and B15. So use the standard 5-point formula to calculate u5. Then use the diagonal 5-point formula to calculate the diagonal values u1, u3, u9 and u7. Okay. So after getting the diagonal 5-point formulas, now the intermediate values u2, u4, u6 and u8 can be determined using again the standard 5-point formula. So once again I will say, so you have to determine first the value of u5 using the standard 5-point formula, that is using the values of B11, B7, B3 and B50. Then you have to determine the values of U1, U3, U7 and U9 using the diagonal 5-point formula. Then you have to determine the values of U2, U6, U8 and U4 using the standard 5-point formula. So you can use the Gaussian iteration method for solving this. Okay. So this is the Laplace equation method. So a problem has been given here. See, there is some mistakes regarding the points. Just determine the value according to the details which are given here. So the boundary values are given. That is, it is said that the boundary or the conditions which are given in the boundary are symmetrical. That is, the boundary values are 0, 500, 1000, 500, 0. This is 0, 0, 0, 0. Again, the values will be 0. This is 500, then 1000, and again it is 500. Okay. And this boundary values are again 0, 0, 0, 0. So this is U1, U2, U3, U4, U5, U6, U7, U8 and U9. So you have to use the, as owing to symmetry, we can say that U1 is equal to U3 is equal to U7 is equal to U9, right? And U4 is equal to U6 and U2 is equal to U8, also U5. So actually we need to find only the values of U1, then U2, then U5 and U4. So these values are only enough, because owing to symmetry, we can say that U1, U3, U7, U9 are equal. U2 is equal to U8. Similarly, U4 is equal to U6 and finally the mid value U5. So again we can start with the standard 5-point formula to determine the U5. First determine U5, then use the diagonal 5-point formula to determine U1, U3, U7 and U9. Then use the standard 5-point formula to determine U2, U4, U6 and U8. So again repeat the iterations. So the iterations has to be repeated. Okay. So finally we will be determining the number of iterations. You have to write the number of iterations till the value of U1 remains the same. U2, U3 as well as, U4 as well as U5. So this is the procedure.